Okay, we're looking at problem number 26 from chapter 6 on page 302. It's talking about job interviews for a group of math and statistics students. It's a good example of at least one. So the first thing it makes clear is that we have 3 math majors and 2 stats majors. And yes, a math and a stats major are a different thing. So in part A, it says the probability that both selected students are statistics majors. Well, the probability that the first one is a stats major is simply 2 out of 5. And since you're going to pick a different student the second time, this is a conditional probability because the second student being a stats major is 1 out of 4 because there's only 1 stats student remaining and 4 total students remaining. And that gives you an answer of 1/10 or 0.1 for part A. For part B, it wants to know the probability that both students are math majors. So in this case, the probability of the first one being a math major is 3/5. The second one goes to 2/4 because you have 1 less math major and 1 less student overall. So therefore, that will be 3/10. Now, for part C, the probability you have at least 1 stats major. The way that would be denoted is the probability that I have at least 1 that is stats. Or you could use notation to say the probability that the number of stats majors is greater than or equal to 1. Now, if you think about it, you are actually talking about multiple different possibilities. If you think about your sample space, you could basically have 2 maths, a math and a stats and a math, or 2 stats. And all of these 3 would be included within that sample space. Now, we could find those 3 probabilities separately, but the trick that will help you with at least 1 is if you realize there's only 1 that is not included. If I could find out the probability of this one right here and basically get rid of that 1 possibility, it would be a quicker way to get the answer. So, the way I can get rid of that 1 possibility is I can, instead of thinking about it being greater than 1, I can say that probability is equal to the probability that S is not equal to 0. So greater than is basically saying that at least 1 means it's not none. Well, that probability of not being equal to 0 is 1 minus the probability that I do end up with 0 stats students, which is the same thing as saying I end up with 2 math majors. Well, we've already found the probability of ending up with 2 math majors was 3/10, so the answer for C would be 1 minus 3/10 is a 7/10 probability. Once again, you could find this probability by finding the 3 underlined ones in yellow and adding them all up, but it's a lot better to do it this way because as your sample space gets larger, that's a much more efficient way to solve the problem. Finally, it wants to know the probability that the selected students have different majors. Well, in that case, what I'm doing is getting rid of the possibility of them both being math and the possibility of them both being stats. So I could basically do, for part D, 1 minus 1/10, which would be both stats, minus 3/10, which would be both math, and that would leave me with 6/10 or 3/5. Of course, I could have just taken my answer for part D and subtracted 1/10 from it, since my answer for part D was equal to what I just circled there, the 1 minus 3/10. But starting back at the beginning, you could also get it that way.